Let's define y to be the number of errors on the first n pages of a newspaper. And once again, applying the scaling property of Poisson distribution, y is going to follow a Poisson distribution of 1.3 multiplied by n. It is given to me that the probability when y is less than 2, this is less than 0.05. The probability when y is less than 2 means probability that y is equal to 0, or the probability that y is equal to 1, and this is less than 0.05. Applying the formula for Poisson distribution, the probability when y is equal to 0 can be represented by e to the power of minus lambda minus 1.3n, then lambda 1.3 n to the power of 0 divided by 0 factorial. The same for this will be e to the power of minus 1.3n, 1.3n to the power of 1 divided by 1 factorial. This is less than 0.05. This is e to the power of minus 1.3n. This is 1. And this will be e to the power of minus 1.3n. Here I will just have a 1.3n. This is less than 0.05. Let me factorize out e to the power of minus 1.3n. So bracket 1 plus 1.3n is less than 0.05. What we're supposed to do is to find the least possible value of n. And since n over here is an integer value, so I'm going to make use of the table from my graphing calculator to solve for the least possible integer value of n. So on my calculator, this column here is going to be n. This column here, the y1 on my calculator, is going to represent e to the power of minus 1.3n, 1 plus 1.3n. And if I were to scroll down the table, when n is equal to 3, this here is going to have a probability of 0.09919. We need something that is supposed to be less than 0.05, and when n is 4, this is 0.0342. It is less than 0.05. And when n is equal to 5, the probability is 0.01128. So the least possible integer value of n is 4. So least n is going to be equal to 4.